Unit 5B, Lesson 4, compare different types of functions. So this is going to be similar to what we did in the previous unit. Towards the end of those last few lessons, using our knowledge of notation, properties of functions in order to compare them and answer various questions. The first example, as x increases beyond 25, which function will have the largest value? I believe we looked at a question like this earlier in the year. So what we could do is plug 25 in for x in each function and then compare what those corresponding y values are. So we plug 25 into all the functions. F of 25 is approximately 25,251. G of 25 is 40.5. H of 25 is 937.5. And then K of 25 is 24,375. So two of them are very close, but we can see that f of x is larger. So the correct answer is going to be A. And what this question is getting you to recognize is if we have an exponential function compared to this one is a linear, a quadratic, and then a cubic, all three of these are types of polynomials. An exponential, as long as this base, which is 1.5 in this case, as long as that's greater than 1, eventually as x increases, as x starts to get very large, exponential functions are going to start growing much more rapidly than polynomial functions. So this would be even more extreme if, say, we made x 50s rather than 25. The value of this exponential is going to be extremely large compared to these three polynomials. Now to example 2, if f of x equals 3 to the x and g of x equals 2x plus 5, at which value of x is f of x less than g of x? So which of these following x values is the function value for f of x going to be less than that of g of x? What we can do is simply plug each of these x values in and then compare what the y values, the function values are. Plugging these values in, f of negative 1, that would be 3 to the negative 1 power. Remember exponent properties earlier, we always want to make a negative exponent positive, so we move that to the denominator and get 1/3. F of 2 would be 3 squared, which is 9. F of negative 3 is 1 over 3 raised to the positive 3 power, which simplifies to 1 over 27. F of 4, 3 to the 4th is 81. Now we plug in these values to g of x. 2 times negative 1, negative 2 plus 5 gives us 3. 2 times 2 is 4 plus 5 is 9. Negative 3 times 2 is negative 6 plus 5 is negative 1. And then 4 times 2 is 8. 8 plus 5 is 13. Now we have all these function values, the y values, and we want to compare for which x value is f of x less than g of x, and it turns out to be the first one, for negative 1. We have 1/3, which is less than 3. For an x value of 2, they're both 9, which is equal, so f of x is not less than. 1 over 27 is very small, but it's positive. That is greater than a negative value. And then 81, obviously greater than 13. So the correct answer in this case is going to be choice A, the x value of negative 1. Now to the last example, Michael has $10 in his savings account. Option 1 will add $100 to his account each week. Option 2 will double the amount in his account at the end of each week. Write a function in terms of x to model each option of saving. Michael wants to have at least $700 in his account at the end of 7 weeks to buy a mountain bike. Determine which option or options will enable him to reach his goal. So if we look at option 1, where it's adding $100 to the account each week, that's going to represent a linear function. So if we set up a of n, which represents the amount in the account after n weeks, that's equal to 100n, $100 times the number of weeks, plus 10, the original amount. Option 2 is if that amount is doubling at the end of each week. So we would have a of n, the amount in the account after n weeks, equal to 10, the original amount, plus 1 plus the rate. If it's 100%, that means it's double. It grows by 100%. That's 1 as a decimal, raised to the n power, representing the number of weeks. We can simplify that down to 10 times 2 raised to the n. Now we can see that doubling, the 2 represent the doubling of the account. Now all we have to do is plug in 7 for our value of n to see which option allows him to reach his goal. So for the first option, if we plug 7 in for n, we could see that's going to get him $710 in the account after 7 weeks. For the second option, if we plug in 7 for n, we get $1,280. That's how much would be in his account after 7 weeks. So to answer the question, both options are going to work to get him enough money to buy the mountain bike. It's just that if we look at the second one, that is going to produce a lot more money in the account because it's an exponential rather than a linear. So both options work. The second option would create even more money for him to have in his account after that 7-week period.